My name is Kyla Taylor, and I will be presenting on the OHAT approach to assessing risk of bias in individual studies, or individual epidemiological studies to support evidence integration and public health decision-making. So quick disclaimer that the views and opinions here don't necessarily represent the views of NIEHS, NIH, or the US federal government. So today's talk, I will be giving a very brief introduction to the Health Assessment and Translation Group. We are formally known as OHAT, but our name has since changed, but the name of our tool remains the same. A very brief background on risk of bias. I think we've all become familiar with that. And then I'll talk about our risk of bias tool and the domains that we use for observational studies in humans and how we make risk of bias judgments. We assess risk of bias in individual studies, and we also use that assessment of risk of bias across a body of evidence. And risk of bias is also important in evidence integration. So this is the Health Assessment and Translation Group. We are at the Division of Translational Toxicology at NIEHS, which is also formerly known as the National Toxicology Program. We serve as an environmental health resource to the public, to government and regulatory agencies. We develop and apply innovative approaches to produce fit-for-purpose literature assessments to support public health decision-making. And a lot of our time is spent conducting literature-based evaluations, and this can include lots of different types of products. We have NTP monographs and research reports, hazard assessments, systematic reviews and meta-analyses, and systematic evidence maps. So risk of bias, as we know, is a systematic error deviation from the truth. It can lead to an underestimation or overestimation of a true effect. So in this figure here, if the blue line is the true effect, which we wouldn't know, and the observed effect is this black line, the bias in this study would be biasing towards the null, or the true effect would be underestimated in this case. But actual bias can't be measured, unfortunately. However, the potential for bias can be systematically and transparently judged by an experienced reviewer. So why do we assess risk of bias in a systematic review? I think Julian Higgins said something about how risk of bias is critical to a rigorous assessment, a rigorous evaluation. It's important that this assessment be transparent and consistent across a body of evidence. We assess risk of bias as the third step in our systematic review process. So the first step will include planning and protocol development, followed by identifying the evidence, which is where we conduct a literature search and screen studies, relevant studies, based on our PICO statement. And then the third step here is evaluating the evidence, and that is where we assess risk of bias in individual studies. Following that, we have our evidence integration. So this risk of bias assessment is important and informs our assessment of confidence in a body of evidence. So the OHAT approach takes a parallel approach to assessing risk of bias in human and non-human studies. We integrate evidence, both human and animal, and we assess risk of bias in both. But our approach allows for consideration of risk of bias across the evidence streams by using common terms and categories. So this is kind of our overall tool here. It has 11 risk of bias prompting questions. And depending on the which questions you are using in assessment depend on the study designs that are included. So each question is relevant to different study designs. So for example, the first question, was administered dose or exposure level adequately randomized? That question is only relevant to the experimental animal and the randomized control trials. I'll get some water. And so the green, I got it. Okay, thanks. The green boxes are showing which study designs are relevant for which questions. And this is a domain-based approach. Risk of bias domains are listed there on the left. So since we're interested in observational studies, this is highlighting which questions are applicable to the human observational studies, and that includes the cohort studies, cross-sectional studies, case cohort studies. The bias domains that we have highlighted here: selection bias, confounding, attrition and exclusion, detection, which includes exposure characterization and outcome assessment, selective reporting, and other sources of bias. That's where you might, depending on your assessment, want to consider funding source of a study or whether appropriate statistical analyses were used. We have 4 risk of bias judgments for each domain, and these are definitely low, which is direct evidence of low risk of bias practices, probably low, which is indirect evidence of low risk of bias practices, probably high, which would be indirect evidence of high risk of bias practices, and definitely high, which is direct evidence of high risk of bias practices. You'll notice that not reported is assumed to be equivalent to a probably high risk of bias judgment. And so how do we make these judgments? We use specific guidance to assess the risk of bias, and this guidance helps the reviewer choose which rating to give for each question. And that guidance will change across evaluations. It's topic dependent. This is especially true for the exposure assessment, outcome assessment, selection, and confounding domains. So when we do our assessments, we develop project-specific protocol with customized risk of bias guidance. This is developed with input from subject matter experts and technical advisors. That's very important when we are creating a protocol. And the protocol is also peer-reviewed, and within that protocol is the risk of bias assessment. When we assess risk of bias, for each question, study question, that's also the time when we would consider direction and magnitude of the bias. So for each individual risk of bias question, we use project-specific criteria to determine if an individual study fits into one of the 4 rating options. So that's kind of how we approach it. Which of the 4 options does this particular study best fit into for each question? And the example that you're seeing here is from our monograph on traffic-related air pollution and hypertensive disorders of pregnancy. This is describing the criteria for a definitely low risk of bias in a cohort study for the question of, can we be confident in the exposure characterization? And as I alluded to before, the differences kind of between a definitely low risk of bias and a probably low would be definitely low requires direct evidence that a study meets the criteria, whereas probably low would have indirect evidence that the study meets that criteria. This slide is just to show that we create the criteria for each of the 4 different ratings when we are doing an assessment. And the general rule of thumb is that green is good and yellow and red are less good. We use HAWK, like Krista presented on earlier, for data extraction and doing our risk of bias assessment. It's a very useful tool. It's free and publicly available for use, and you can customize it for your particular assessment. This would be the view of an individual reviewer in HAWK when they're looking at a question, and this one is on selective reporting, where all measured outcomes reported. The reviewer can choose the judgment from this drop-down menu on the left and the direction of bias if that can be assessed. Oftentimes it's very difficult to assess that, if at all. And then the most important part here, I think, is this text box where the reviewer puts in their rationale for that judgment. And that's a really important part of this process, and it kind of forces the reviewer to be very familiar with both the criteria and the study that they're assessing when you need to provide your rationale. So we have 2 independent reviewers assess risk of bias for each of the studies, each of the questions. This would be kind of a look in HAWK from a tertiary reviewer or whoever is running the project. 2 reviewers assess, and you can see here in this case there were different. One reviewer gave this attrition definitely low risk of bias with their rationale underneath. The second reviewer gave a probably low risk of bias with their rationale. It's then the job of the 2 reviewers, the study team, to discuss which is the more correct answer. And that process is also very important and critical to our risk of bias assessment. We think that's much more important than something like inter-rater agreement in terms of determining whether a tool is useful or not, how useful a certain risk of bias tool is. Those discussions rely on expert judgment and consensus. And then what would be in your final assessment would be what you see on the bottom part of the screen, and that's kind of the agreement that the study team came to. So this pie here on the left of the screen is how we would view risk of bias in HAWK for an individual study. For this study, some of the domains got probably high risk of bias while the others got low. You can click on the different domains, and when you're in HAWK, and the rationale for why that study got that particular rating will pop up. So we also don't give individual studies an overall risk of bias rating or score. That's because, as Holger talked about, not all of the domains contribute equally to an overall risk of bias in a study. Some of them are more influential than others. And so in observational studies, typically key domains include confounding bias, exposure characterization, and outcome assessment. And what that looks like across studies in this heat map here, so we might look at this and think that these two studies here are the most informative, and lower risk of bias studies typically are the most informative for developing conclusions. I'd say we rely on those the most. But we don't exclude studies from an evaluation if they're higher risk of bias. And that's because they can provide very important relevant information and can be used in sensitivity analyses. We typically will, if we have a good body of lower risk of bias studies which inform our conclusion, then we'll typically just summarize the higher risk of bias studies and describe the most important factors that are making them high risk of bias. So another thing I wanted to mention with that is we can also look at the different domains and the risk of bias across domains. And if we're considering direction of the bias, we can kind of determine if we can rule out concern for any of these different domains. An example of that might be ruling out your concern about confounding in studies. An example of that would be your whole body of evidence, both higher and lower risk of bias studies are consistent in their direction of the effect or direction of the association, which is what we're interested in when doing hazard identification. And if those results are still consistent, despite different studies adjusting for different confounders, we might not be as concerned that the confounding is impacting our overall takeaway conclusions from what those studies are showing us. Another example might be exposure. If we are seeing that, are able to determine that exposure misclassification might be underestimating a true effect, we might not be as concerned with that. That's why one of these more informative studies includes a study with exposure that is at probably high risk of bias. If we're thinking and maybe the direction is towards the null, we might not be as concerned with how that impacts our overall conclusions. So to summarize, our risk of bias tool in OHAT has 6 different domains for observational studies and 7 risk of bias prompting questions. We have these 4 response options. A question came up in the workshop yesterday about why we have 4. We have this because when we were developing the tool, we found that if there were like an odd number of options, like 3 or 5, and a reviewer isn't quite sure which way to go, they might tend to choose like the middle option. Having these 4 response options kind of forces you to choose, which is important to make decisions when you're doing these assessments supported by your rationale. So we assess the risk of bias in individual studies in our systematic review process, And then those risk of bias, the risk of bias assessments across studies is used to support our evidence integration, where we typically rely on the lower risk of bias studies for our conclusions. And then risk of bias, we use a kind of a modified grade approach to assess our confidence in the body of evidence, where risk of bias is an important factor. And I'd like to acknowledge the rest of my group, and thank you so much.